All right, so for this, we're looking at cones and spheres and variations of those. And for the first question, I have a right cone. A right cone that has a base radius of 3 centimeters and a perpendicular height of 7 centimeters. So let's start by making a quick sketch of this. And so right cone just means a cone with a circular base, and the height is at a right angle to the base. There's my quick little sketch, hope you enjoyed it, of my right cone. All right, so what do we know? It has a base radius of 3 centimeters, so this distance here is 3 centimeters. I'll split 3, and it has a height of 7 centimeters. So this distance here is 7. All right, I want to find the surface area rounded to the nearest whole square centimeter, and I want to find the volume, but as an exact expression. So let's first look at surface area. And surface area of a cone, well, if the cone really has two pieces. It has if I want to find the surface area of it, I have the outside curved part, which is always the same as pi times the radius times L, L being the length of this slant right here. So I'll label that L. And so pi times r times L, that's the length of that slant. However, there's also the circular base, and that's just pi r squared, so plus pi r squared, and that radius being the same in both. All right, so for this, I want to figure this out using my value being decimalized in the end and rounding to the nearest whole number. So we hit a slight little roadblock pretty fast. We get pi times the radius, which is 3, times L, which I don't immediately know. So I need to put this on hold. I need to find the length of L, that slant, which, keep in mind, if I look back at my diagram, is the same thing as right here. And hopefully we can see that I am creating a right triangle. And this right here is a right triangle, which L is the same as the hypotenuse. We have a base of 3 and a height of 7. And so let me just right here figure out L. And so L will be the same as the square root of 3 squared plus 7 squared, which is the square root of 58. Which I don't actually care about the decimal approximation right now because I like root 58 better. It's easier to say, it's easier to write down, and it's more exact than some decimal approximation. So there's my length using the Pythagorean theorem. And so coming back here, I got 3 times root 58. And so pi times 3 times root 58, that's the surface area of the curved part around the outside of the cone. And then there's the actual circle, which is pi times the radius, 3 squared. At this point, you can, if you're wanting to just go straight to a decimal approximation, or in this case, a whole number approximation, I will just type this into your calculator, pi times 3 times root 58 plus pi times 3 squared, and it should round to 100 square centimeters. All right, so now the volume. I'll do this right here. Volume of a cone is 1/3 times the area of the base, so pi r squared times the height. So in this case, I don't even need the length of L. And quite often we find volume is a little faster than surface area, so I have 1/3 times pi times the radius, which is 3 times 3 squared, times the height, which is 7. Now for this question, we're asked to have the volume expressed exactly. So I don't want to go to my calculator and evaluate pi times any of this. However, I can clean this up a bit. I have 1/3 times pi. I have 3 squared times 7, which is 9 times 7, which is 63. So I have 1/3 times pi times 63. 63 times 1/3, same as 63 divided by 3, which is exactly 21. So I have 21 pi. So that there, 21 times pi, that's what we call an exact value, because if I want to change this to a decimal, it's no longer exact. Remember, pi is not exactly 3.14, pi is approximately 3.14, and no matter how many decimals you have, it's never exact. And so this is my answer, my exact answer for volume once I put the units, which is centimeters cubed. And so we call this an exact expression, and we call this a decimal approximation. We want to understand both. In general, when you're dealing with shapes like cones and circles, our exact expression will always be multiples of pi, because it's the pi part that keeps us from making an exact decimal. All right, I have a hemisphere, which means half a sphere, and I give some coordinates. The origin is where the center is, 0, 0, 0, and point A is at -6, 0, 0, which tells me this radius from here is 6 units. Now, in the question, it doesn't tell me what the units are, so just 6 units. That's my radius. All right, I want the exact surface area and the exact volume of a sphere. So I'll start with volume first because it's a little bit less work. So volume of a sphere is 4/3 pi r squared. That's a full sphere. So for this, I have half of that. So it's all this divided by 2. Well, keep in mind 4/3 divided by 2, same as 4/3 times a half, same as 4/6. Or 2/3, but I'll leave it as 4/6 for now. And so this formula is fine, but it's a little bit nicer not to have a fraction inside a fraction. So I'll have 4/6 times pi r squared. However, the radius again is 6. And at this point, I can go to a calculator, although I don't want to multiply pi by anything. For example, 6 to the power of 3 is, sorry, that should be 6 to the power of 3, not 6 to the power of 2. 6 to the power of 3 is 216. So I have 4 times pi times 216 over 6. And again, I want to keep this exact. So if you just go 4 times 216 divided by 6, you get, in this case, a whole number. You get exactly 144. So 144 pi is my volume. There's no units here, so I'll just say 144 pi. I'll just say cubic units. So for surface area, which I also want to keep exact, surface area of a full sphere is 4 pi r squared. That's the surface area of a full square. Sorry, a full sphere. I have half a sphere. So part of that is, instead of a 4 there, I want to cut that in half and make it 2. However, just that alone doesn't take into account this circle at the bottom here. So that's not enough. I need to have this plus the area of that circle, which again is pi r squared. And like before, the radius is 6, so I have 2 times pi times 6 squared plus pi times 6 squared. And keeping this exact, there's many options I can get to here. But in the end, this should come to a total of 108 pi. And that's found by, for example, here you get 2 times 36 plus another 36. If you add that all up, 2 times 36 plus another 36 is 108. Just remember, though, if you want an exact value, I don't want to actually multiply pi out, or a decimal approximation of pi. And this is the surface area, so this is in square units. So mathematically, answers like this, 108 pi and 144 pi, are quite often considered better than a decimal approximation because they are exact, there's no rounding, and they tend to be a bit cleaner. In practice, though, if we want to use a value, we want to decimalize them. If I have to measure something, I'd rather know how many centimeters it is as a decimal than 24 pi. So it depends on the context. All right, so I got this ice cream cone here, and we want to imagine a slightly simplified version of it where we have, instead of this little bit of ice cream here kind of dripping off, we want to imagine it being a perfect hemisphere, so a perfect half sphere on top of a cone that matches it perfectly. So we're just slightly simplifying the details of this image. Good enough. So what do we know? We know it has a height of 8 centimeters. So the height of 8 centimeters, that's the cone. So that's from here to here. That is 8 centimeters. And a hemisphere with a diameter of 8 centimeters. So it's 8 centimeters all the way across. So instead of writing 8 centimeters all the way across, these are both the same, and I'll say they're both 4 centimeters. Because that's the radius, and that's quite often more helpful. And I would like to find the total volume and total surface area of this composite shape. So usually volume's a little bit simpler, so let's think about volume here first. So the volume of the hemisphere, which is a full sphere divided by 2. We saw that in the last one, so I can just write this as 4/6, which again reduces, but I just more want to get rid of that fraction over a fraction. plus I have the volume of this right cone, which remember is 1/3 pi r squared height. And so we have everything we need here. The height is 8 centimeters. The radius is 4 centimeters. We are looking for the answers rounded to 1 decimal place. So I don't want to leave my answers as an exact expression. I want to decimalize them. And so at this point, I have 4/6 or 2/3 times pi times the radius, which is 4, all to the power of 3, plus 1/3 times pi times the radius squared times the height. And at this point, it's a matter of arithmetic in your calculator. Depending on how confident you are with your calculator, you should get it rounding to 268.1 cubic centimeters. And so surface area will be a little bit more work, which is fairly typical. And so the surface area of this composite shape is at the hemisphere, which again, a full sphere is pi r squared. That's the surface area of it. I have just half of that, so chop that in half. This time I don't need to worry about this circle right here that I'm drawing because that's not part of the surface, so just 2 pi r squared covers the ice cream part, plus all I need is the outside of this cone, which remember, just the outside of a cone is pi r L. L being the length from here to here, which we don't yet know. But it's very similar to what we did at first. And so before I go on, I need to figure out the length of L. And if we do the same thing, if I look at this fairly messy triangle here now, I'll make it a bit darker. The distance from here to here is 4. The distance from here to here is 8. This is a right triangle. So L can be found as the square root of 8 squared plus 4 squared. Which we should get to root 80 fairly quickly. Again, I want to eventually decimalize this. I'll just leave it as root 80, even though I'm going to my calculator. Root 80 is easier for me to type in than some endless decimal. And again, the radius we already knew was 4. And so now, again, it's a matter of just the arithmetic and being careful with my rounding. So 2 times pi times the radius, which is 4 squared, plus pi times the radius times root 80. And that's taking this step and going here. And again, at this point, it's a matter of using our calculator, feeling confident with it, and rounding properly. It should get about 212.9 square centimeters. So there's your surface area rounded accurately to 1 decimal. Here's your volume rounded accurately to 1 decimal.